Hello and welcome to the shader chopper task. In this task we are going to make the chopper shaded. So what we want to do is we want to have this chopper here, but then this will have a gradient. So one side of the chopper is lighter and the other side is darker, and there is a smooth gradient from dark to the light. And what we have to do is we have to use the vertex shader and fragment shader for this. And the code for JavaScript is a new code, but for C++ we will reuse the old code. So we will use the same code as the last time from the cube chopper task or the flying chopper task. So what you should have done is you should have add the init chopper and the create cube already in it. But you might have to change the create cube function a bit, and I'll explain it a bit later. Draw chopper is also the same, and everything is the same. What we want to change in the create cube is that we have a color input, but now we want to have a lighter or darker color as well. And what we want to do is have half of the vertices light colored and the other half dark colored. For example, 0, 1, 2, 3 have a light color, and 4, 5, 6, 7 have a dark color. That way there is a gradient from one side to another. We don't want to have them randomly. For example, 5 is light and 1, 2, and 6 are dark. That would make it look a bit strange. And one more thing we want to do is that we want the gradient from left to the right for the chopper body. And for the plates, we want the darker side to be in the center and then get lighter as we go to the edge. And for that, you might have to change the rotation of one of the blades so that the darker side is in the center. And there's also example image in the task description as well. But I'll first show you the vertex shader. So the vertex shader has we have three different parts here. We have the uniforms. We already changed the model matrix last time, but we also have view matrix and projection matrix. And then we also have in and out variables. So we take the position and color in. So this is the information in the vertex array object, the VAO, if you remember. So it has positions, colors. We also have an out variable, which is the interpolated color. And we can see that interpolated color is assigned to the color. And as we go from light to the dark, from one vertex to another, if they are connected by being in one triangle, then the gradient will become apparent. So what we had there was local space vertex. So let's indicate it with V, and I'll give you an example. For example, we have this cube here, and this has the local space variables, so local space positions for each vertex. So if you remember from last time, the cube had like -1, 1, 1, and etc. But if we only had these positions, then we couldn't like move the cube and have multiple cubes together like we had in Chopper. So what we did, we changed the model matrix. So let's say that this here is the world origin, which means that the 0 coordinate is located here. The model matrix is the matrix that will convert the local space coordinates into world space coordinates. So now instead of it being between 1, 1, -1, etc., it's like 1000, 1, and -1 might have been rotated, etc., etc. So now the coordinates are in a relation to the center of the world, not the center of the object. Then we had the view matrix. And view matrix is another like transformation that we have to do, because now we have a camera in our world. So we have a camera in our world, and the camera has a rotation, it has a location, it has all those different properties. So we want the cube's vertex locations to be in relation to the camera. So what we do is we have this V matrix, right? Oh, that's the other way around. So we want to convert it into view space, is what it's called. So this is, the cube is by default in local space, then it's in world space when we multiply it by M, and then it's in view space when we multiply it with V. And finally, we have a projection. So we talk about projections in future lectures, but the gist of it is that we might have a perspective camera, we might have orthographic camera, we might have some different projections, and projections have this thing called frustum, which is a space, and we want all the coordinates to be like between -1 and 1, and that will be squished to the screen in GPU. So that transformation from view space to this projection space, which is like -1 to 1, this has to be done with P. So let's say that we have this cube like frustum, and we have this like cube here somewhere. So we want to transform here into P. And then the process of converting that projection space into screen space is done in the GPU automatically, so we don't have control over it. But now, yeah, we have this BVM V, which is our position, and sometimes we multiply these matrices together beforehand. For example, we might convert this V and M into one, so it will be view model matrix, or model view matrix. So model view, but we might also multiply the P, V, M together at once, so we don't even have to do any matrix calculations in the shader. So that would be model view perspective matrix. Not perspectives, my apologies, projection. And yeah, that will convert the V from local space to the projection space. And in the code, we can see that's what we are doing. We have this local space position. So that's the cube corner coordinates that are like -1, 1, 1, or all the other 8 possibilities. We multiplied by model matrix. By the way, we put this one here so it's in affine space. We multiplied with model matrix, then we multiplied view matrix, and then finally projection matrix. And all of these are defined in our code, right? So we have the uniform model matrix in our throw hanger or throw chopper, but we also have the perspective camera, so we have projection matrix, and we have the view matrix. So those two have already been set in the main function before the main loop. And yeah, the GL position is sent to the fragment shader. And in fragment shader, that's the shader that is run for each fragment, so each pixel, as opposed to each vertex. And in fragment shader, we just take the interpolated color. So we had the out here, now it's in, and then the out is the frag color. So what's the color of that pixel? And we just put the interpolated color. Yeah, in this task, you don't have to change the shaders, but what you have to change is the colors that you give the cube vertices in the create cube. So remember, half of the vertices has to be another color. And you also have to change the throw chopper so that the gradients are in the correct direction. We want the gradient to be from one side to the other, so we can actually see it on the chopper. And also the blades we want them to have so that the darker color is in the center and it gets lighter as we go further out